Teacher, you mute yourself.
Yeah, I'm still waiting for your friends. We'll start in 3 minutes.
Okay.
Yeah. Okay. By the way, I will ask you to do one quiz, so be prepared, please. Yeah, I say that we will have a quiz. Now, okay, everyone, so welcome back to this session. Okay, so we are last time we were working on the stack and queue. Okay, so now the thing that we have to remember for this stack and queue is that we are working on the data structure that can be used as a tool. Normally it's not just to store data, but we want to use it as a tool so that we can perform some apply some policy to our data our items stored in this data structure. For array, just the storage. But for the stack and queue, we have some properties like first in, first out, or last in, first out. It depends on the policy, so we will use the corresponding data structure. Okay, and the data structures are abstract, means people just want to have some properties, some functions, but they don't care how you implement it. Means that I can implement using array, using linked list, tree, whatever you have later on. Okay, so that the data structure at the tool, and we have the stack. Okay, we see that it's quite straightforward. That stack have last in, first out. Then we have push, pop, and pick operation on top of that. Okay, and now we have another thing like implementation. So we want to say manage the size of a stack. We want to check on the number of items in a stack, and we compare the items. Okay, and so on and so forth. So we have the operation like a push and then pop operation for a stack. Okay, with that you see that one direct application is because it is first in, last out. So we can use it to reverse an array, or we can use it as a tool to check the delimiter, check it matching. Okay, open and closing parentheses. Okay, then we have example on this, and we have the code. When we talk about implementation of a stack, we say about the complexity, because that is kind of a requirement for people. When we use it, use a stack, they always assume that the operation must be a one. Okay, and then we have the queue. We have slightly different, but different policy is first in, first out, and we have different like operation in queue and DQ. Okay, and now when we say we have in queue and with DQ, we have the rear in the front. We see that the direction that the item go in and out. Okay, we have this one. We can DQ like this. We have application. Okay, we have this one. Now, last time we stopped here where we have the way to implement the queue using an array. Okay, and you see that if we implement it like insert first, insert last, that will be not okay in terms of complexity, because one of them will be on. Okay, then people think about circular queues when we try to implement it using array, but the way that we use array is different from the usual the normal ways that people do the insertion and deletion from the array. Okay, now we have two pointer in the front and the rear, and then we just try to move them around. And as a homework, I do ask you to like check the implementation of that. Okay, now time for a quiz. Okay, I just want you to assume here I will tell about the quiz, and then you have to submit it to a paper. I will. Okay, assume that you have two one queue and one stack. Okay, now my question is, I want you to compare the content. This means the content, the items stored in this data structure, this variable. Okay, to check whether or not they have the same set of items. That is your operation. Now I want you to implement the function. Okay, is it clear, everyone? Hello? Means that assume that you have your data structure, you have the code that we can have the, I assume that we have a class named my stack, another class named my queue. Okay, they have some data inside already. Now your task is to write a function to compare the content in these two data structure. Okay, is it clear, everyone? Yeah, you have to compare the item inside the queue in the stack. Okay. So what I say, I will make a blank space. This one I will write. Oh, sorry. Let's say here the stack. So here your queue. Yeah. No, not the same size, but the content of the queue and the stack, are they the same? Okay. Let's say the front here and the rear here. Okay. So if I want to check, there's many ways to say they're equal, but I would say this one. Okay, so when I say the same means that the front of the queue is the same at the bottom of the stack. Okay, and the rear of the queue is the same as the, it means this like this. Okay, do you get the question? So if it's not clear, please ask me. Okay, so use the operation like use operation on stack and queue. Okay, means that you can only use the pop, push and pick for the stack. Okay, and in queue, DQ for the queue. Okay, you cannot say go through the array that implement the stack and the queue and compare. No. Okay, I want you to implement it that way. Just a way to have to say get familiar with operation on stack and queue. Okay. Yeah, you can use the implementation stack, whatever you want. Yeah, but I assume that we have some guy, someone like a Java or somewhere implement the function stack and queue for of the stack and queue for us. Okay, now we just want to use them. You know? We are not working on the implementation, but now we try to use it. Okay, you can always declare my stack, whatever you have, and then you have my stack dot push and pop and things. Luận, I don't know what do you mean by randomly use operation. What do you want from? What do you want to ask? I asking you to do it, Long. What do you want to ask? I want to ask you to do the quiz, like how to compare. If you have to tell me. And in the screen, you see? Do you see it? I define what does it mean by equal. So whether or not they are the same means that the stack, the bottom of the stack have the same value at the front of the queue and so on. Is it clear, Long? Okay, everyone. So can you finish it? So please like when you finish. Okay. So everyone, so now let's try to discuss the way to do it. Okay. So first of all, like can some of you share with us the way it's been your strategy or your algorithm, how we can compare it? What should we do? What can we do? No? Someone? Mm-hmm. the one that you do tongue is not what we have tongue. Tongue in your solution tongue you do it quite in the opposite direction. So in your solution tongue you in your case you try to compare it either top or the stack and you compare it with the bottom of the front of the queue is not correct. No, the thing is that yeah we should somehow play with the stack, because the way we access the data from the stack is what? When we read it, the output of the stack will be from the top 79 and then 32, okay, and then 6 and so forth, okay. So because we access the stack from the top, and for the queue it is opposite. We get 12 first, okay. So what can we do? The way is that somehow we should access the stack and reverse and put it in the right order, like reverse the content of the stack or reverse the content of the queue, so that we can make them like a alignment. Or what we can just do is store this one to a normal array and then compare with the stack one by one. That's it. Now pop the value out of the stack, okay, put it in an array and compare with the queue. Everyone, is it clear that way? No? So here you see that the problem with this comparison is that the content of the stack, we cannot read it from the bottom to the top. When we read out the stack, the data in the stack will be in the inverse order, no? That will be like this. Okay. So when we read from the stack, the first item we have 0 here, 1, 2, 3, and 4. Okay. Means that the data is in the inverse position with respect to the queue data. Okay. When we dequeue, what we get is in the opposite direction. Okay. Is it clear that the data is in the inverse order when we do it like this? Okay. And now we want to do the matching. We want to compare. One of my solutions for you is just pop everything from the stack, store it in an array. Okay. And then compare it with the content from the queue. Okay. That is first solution. Another way that I think, if you can think about that, that will be like the delimiter checker. So I will push the content of the stack to another stack, because we want to reverse the order, no? The stack will have us do that. Okay. And now you see, after we pop the content of the stack and push it to another stack. Okay. What do we have? Now we have the top of the stack. It corresponds to the front. What we do, just like the parenthesis checking, we dequeue and we pop whether or not the same continue, otherwise stop, and so forth. Okay, is it clear, everyone? See it? See the way that we use another stack? Everyone else. So is it clear for you? So this is just like a very important like exercise, a quiz to sum up the use of queue and stack and the access, the limit to access control, well, the access control in the stack and queue. Okay. Do you have any other question on that? The others, please be active. Tell me. Okay. Okay. I hope that you're good with that. So, what do you want? Do you want to? So again, I will ask you to. So do you want to do the to get the code, or you want to do it at home? The code for a quiz, yeah. I would not do the code directly, but I can like show you the way. Okay. Yeah. I will show the code as an idea for you. Okay. So here is in my I have my function now. I have compare and I get my stack. My stack, okay, and my queue, okay, queue, okay. So what we want to compare. So the first step, if I do, there's many ways. I will do the reverse, okay. I will do the while loop. So I say store the get the data out of the stack. Okay. Of course, you can do the opposite, like put the data in out of the queue. Or that will be the same. Okay. Or out of the queue if you want, just whatever you want. So I have my my stack, my like temp stack. Okay. I will create a new stack, okay, with the size in a minute. I do while loop, while my while stack, okay, is not is empty or not. If my stack is not empty, what I just do is just like stack dot pop. Okay, I get the data out of my stack and I put it to my temporal stack. Okay. After that step, what we have everything from my stack here in the input will be in my temporal stack in the opposite direction. Do you agree, everyone? Is it clear up to now? Okay. So what I say is that example, yeah, it is like that. If you want to have example, it will be like my stack like this. Okay, and I have okay. So I have my number there is that say the bottom 3, 2, 1. Okay, and it is for my stack. And after I put it in my this stack. If I do like that, what I got from this is 3, 2, 1. Okay. Okay. So that after that step, what we have now, we just do compare. No? Why the stack is not empty? My temporary tag or whatever you if you want to play the queue is empty. I put it why my queue is not empty. Okay, I will compare. Okay, so if the queue is not empty, I will try to pop the thing. Let's say my data, I will X pop it out from my temporal stack. So we get the data out of the stack. Okay, so and then if you remember the queue is like this. Let's say the queue is 1, 2, 3. Okay, and that is the queue. The queue is this way. The queue in that direction. Okay. The head of the queue is here, and here is the tail. Okay. Okay. And then what we try to do is we try to compare this one with the top. Okay, so I pop it here. It should be 3. Okay, and I compare if what, and then I say from Q. Okay, go Q dot DQ. Okay, yeah, let's extract and then XQ. Q. Okay, if stack are not equal XQ, okay, we return false. Okay, otherwise just continue. Okay, until then, if we exit the loop, means the queue is empty, and if the stack is not empty. Okay, then it's mean there's a problem. We still have some data, otherwise we say. Okay, everyone, that's it. Hope that with this exercise you you get better understanding for the stack and queue, no? Okay. Yeah. Yeah, that is the solution. Of course, at home, if you want to play, I say get the data. Let's try to do like get the data out of the queue, then try to compare with the stack. That will be the same. Okay. Okay, everyone. Any other question, everyone? So please tell me if you have problem, you have question. I really we have time and really want to tell you, to clarify things. Okay. The others, is it clear for you? Do you have any question? There is line number there if you want to ask anything as a given line, ask me. Okay, can we move on? The others. Okay. So now there's one thing. There's one thing I want all of you to know is that now when we play with stack and queue like this, there's one problem. There's one problem. You have to be careful. Okay. And in the lab, in one of the lab section, I will ask you to do it. Is that check on to not alter original? Yeah, that is the thing. That is the thing I want to mention. Is a great observation. So now the thing is we are working with stack and queue. Okay. And you see that the stack and the queue is like this. And the way we access it by default, that would be on the like the first in first out or first in last out direction. Okay, so means that when we do the operation that I show it to you, is that we empty the stack. That is something not really good, like the observation of Nhật. Okay, it's good Nhật, because when we want to compare two things and you somehow remove every data from my content, from my container, from my stack, from my queue, it's not good. Okay, and for my solution, after you do this one, both stack and queue will be empty if they are the same. Okay, so of course that is if we strictly follow the way that we check the stack and the queue, and in real life that will be like that. So you give a stack, like a stack, a piece of paper stacked on top of each other. So now we want to compare whether or not we have two the item in the stack are the same as your list. You have to take out the item from the stack one by one. Okay. And now, what if you want to reserve the original version, what can we do? What can we do? Somehow, first of all, what we say, we can rebuild it. No, after we check, we put it back to the original copy. Pop out and get back. Okay, of course we can do it. We can get it back easily. It take time, okay, for sure. Or there is another way. This is very technical, means that we know that behind the scene, we implement the stack and queue using array or a tree, okay? And the operation, the thing that we want to compare, now we say we are the one that control the data. We want to access to the way that we implement it. It means we access to the array that is internally of the class my stack when they implement it using array or list or whatever. Then we can compare the array behind the scene of the stack and the queue. That could be like that. But of course, you can only do it if you are the one that implement the stack. Okay? Say, that is one observation we can do. Okay, and that is the remark I wanted to tell you. Okay, so conclusion, we can compare, and what we can do, we will destroy the data. Say we have empty the stack. If you want to keep the original version, rebuild it. It means push it back to the queue, to the stack. That's it. Okay, is what we can do. Make a second copy of the stack and so forth. Okay, everyone. Okay. So if someone want to say something. Okay. Okay, so now let's move on. So now continue with this. Any other question or remark or observation? So you can always ask me. Right? I'm happy to share with you. Okay, so okay. So now what we try to do is now please okay, maybe you are overhead somehow already. So now let's move a bit to a priority queue and then we have a short break. Okay. Now, so now back to the data structure. So we have the queue and the stack, and the queue we have one like a special version of that. We call it priority queue. Means that the DQ and NQ will not follow the first in first out policy anymore. Okay, we now try to say we get out the value that have the highest value. We have the most severe patient will be served first. That will be our policy. Okay, so now the priority could be like in descending order or descending order. That could be anything. Okay, and now my question for you, I think like you need some prep to refresh, but let's take 15-minute break. But think about this one. If we want to implement the queue for priority queue with array, what can we do with that? Okay, how can we implement priority queue with an array? Okay, so everyone, so please think about that, and I suggest that you take a 15-minute break to just like a refresh from the exercise and think about a new one. Okay. So everyone, please do it. And of course, during break time, you can always check the solution and then ask me if you still got some problem with that. Okay, I will show it here. Okay, hello everyone, so welcome back. Hello everyone, please like when you're back. Okay. So now, everyone, so we are now let back to this one. So now we try to say like we want to have priority queue, no, that have the input the data, but when we get it out, we want to get it in the priority. Okay, so the highest value will be get out of the stack, the queue first. Now your solution, can you tell me how can we implement this types of queue using array? What can we do? What should we do? Everyone, please tell me. So for this one, let's say we have an intersection. If we use array, is it possible that way, or is it possible to have like a or one for all of the operation for both insert and delete, as mean in queue and dequeue from the priority queue? So what should we do, everyone? Please tell me. Hello. So if we want to have a queue that have highest priorities, I don't know if you can imagine. So that I have a queue like that. So we don't care whatever we have. Like we could put like 8, then 9, then 0, okay, and then 3, okay. And then what we want is that every time we get the item from the queue, that should give us the maximum value, the highest priority, let's say 9, okay. I get out 9 first, okay. Then you ask me to get another item from the queue, that will return 8, okay. And then they will return 3, and then last one will be 0, okay. So see, that is the order of the item that should get out of the queue. Okay. So now let's think about that. If we want to implement it using array, what should we do? Yeah. What we can say is that we can sort the array. Okay. Maybe that you want to sort them every time you insert. Okay. And then the largest item on the first position. That way is not a good, a really good one, because you got the idea. But if you put it in the first position, no, then they have to shift if we get it out. Okay. Okay, Nhật, what do you want to say? Attributes for element in the queue being the priority. It means you say the highest. You have a null pointer that tells us where is the highest priority, no? Nhật. And Tân, yeah. There's one thing from the solution of Tân, like we should, like if we implement it array, you know that if we get it in the first position in the highest priorities, when we remove it, we have to shift everything to the left, so it takes us some time. Okay, so we better put the highest value in the last position so that we can remove it with O1. Okay, Tân? Means the array somehow will put it in like increasing a lot of priority order. Okay, and Nhật, from what I get, I can understand from your comment that you want to maintain a pointer to tell us where is the highest priority, no? Yeah, that way is possible, but then you think about the operation that every time you remove it, what should we do? We have to shift thing, and we have to find the next thing. And of course, my solution is that for insertion, what we can do is if we use array, what we can do, we achieve it on, because we have to find the possible, like a suitable position for a new item, so that we can put the array in the increasing order of priorities, and the highest priority will be the last one. Okay, so if like that, then after we want to delete, it means we want to dequeue, get it out from the queue. What we can say, we just remove the last element, that will be O1. Okay. Okay, that is a way. Now, think about this one. If I do it like in the opposite direction, means that instead of here, I will do the sorting. No, I do the insertion sort, or I find the position and put it there. Okay, and find. Okay, and then to find the position. Okay, so it takes n step to find the position, and then after that we can delete it, dequeue it in one step only. Okay, is it possible to implement it in the invert direction? I mean, can we achieve something like a 1 for the insertion and on for the dequeue? The answer is yes. Means that we say, where on the insertion we don't prepare anything, we should put it randomly everywhere as you want. Normally put it in the last position. I would put my new item at the last position, I don't care. But then next time, every time people want to delete the item, I will say do the search for the max and min. Okay, and find the position like this, say this is only the next, then I do the shifting back to this one. Okay, so it takes us some time, more than the opposite direction. We put it in order and get the last one. Okay, but you see, the thing is that in this way, maybe we have a need to somehow make the priority queue like O1 for both direction, in queue and dequeue. But for the moment, unfortunately, we cannot do it, no, because That is because we had to prepare. We had to find a position. It's not easy. Okay. And that will causes at least one of them must be O1. And another will be ON. Okay. So that is the priority queue. Okay. And here is the way. So we insert and we find the position and put it here. And when we get it out, we get the highest priority there. Okay. So we have in queue and we have DQ. Yeah, let's say we will skip it this way. Now, everyone, I'm sorry that today I try to show you like many things that quite heavy, but like bear with me. Now we are moving to another application that will be interesting operation application of stack and queue in general. That is, we want to write a program, okay, that can help us to evaluate the value of a given expression. Say we say 3 plus 4 minus 5. What we want is we want to get the result of that. Will be 7 minus 5 will be 2. Okay, means we want to write an application that you give any input like that can tell you the result of the arithmetic expression. Okay. Of course, for human being, we learn how to apply like math. We say that we should have the priorities of the multiplication and the division over the addition and subtraction. Okay, and then that is what we learn. And now, how can we tell the computer to do it? It's not trivial. Okay, and here let's try to see the way that we do it if we are human being. Okay, so what we do is we read the numbers like number 3 here. Okay, so we read the next operator is plus, and then we have minus. Okay, and then we have 5. Okay, that's the way we read. But in between, say we 1, 2, 3, 3 plus 4, and then we should read minus, and up to the moment that we see the character minus, we say okay, we can do the addition here, 3 plus 4. Okay, and we make it 7. Okay, and after that we have 7 and we continue, we read number 5 and we say 5 minus 7 minus 5, we have 2. Okay, that is the way that we do normally. And you see that it's not easy to tell the system how we can do it that way. And there's one algorithm people try to do, but they say for the computer we need to have a good, say the stable way to evaluate expression, because we know that the priorities, the parentheses, the addition, subtraction, and everything, division is quite complex. Okay, we cannot do if else for every statement like that. Okay, then what people try to do is we have one solution, is that first of all, we try to convert the expression in some form that easier for the computer to read. So we call it the postfix format. Okay, that is postfix format. And then we evaluate the postfix format. Okay, that is the way that people will do, to evaluate the expression. Okay, and now try to see what does it mean by postfix format. Okay, the way we do is try like this. Instead of writing the notion of A plus B, okay, we try to write like A, B plus. Okay, we'll see the value of that kind of thing. Okay, but now we have this Okay, this example. Okay, now have a look. So we try to convert a plus b minus c. We convert into postfix. That will be like this. Have a look. So we have the ab is the operator of the operation plus. So we say ab plus. Okay, and after that we have this notion postfix, means everything before here means that minus here means that we apply the minus between the subtraction between a, b plus and c. Okay, that is the thing. So now have a look at this. A asterisk b divided by c. So what we have, a, b, like this. Okay. Now this one is special because we want to have priorities of this one over AB. So what happened is that we write, when convert to postfix, it will be A, B, C, and then we have the asterisk, means that we apply the operation multiplication of the two value before this one is B and C first. After that we get the result. We get the result somewhere. After we have the result, we get it back to the block here and we apply the addition. Okay, so you see that way we tell the computer that every time we see the postfix format, where postfix is like we always have two blocks before the operation. So your operation could be anything, but when you read this one, the second one, and then you see the operation, then you can just apply the operation on the top of these two values. Okay, and here you see that we have B and C. We have asterisk, it means multiplication. We apply to B and C. Okay, so we have the first box and finish it, and we then for the second time when we reach the plus, so we have two boxes again. So the first box is A, the second box is B, C. The result of B, C asterisk here. Okay, so finally we get the result as the infix format. Okay, so everyone, is it clear that way? You see the notion, the postfix notion? Is it clear for you? Okay. Now, so what I want you to do, just to play with this one. So check this one. You see that A, B, C, and we see that we just write down A, B, C, then we have plus first because we do the addition on BC, and then we do the asterisk for A and BC. Okay. Now, what I want you to do is we try to play a bit with this. So so check this one on your own. Okay. Try to do it without look at the value here. Without look at the value here. I will unroll it later on. Okay. I will erase it. Yeah. There, the first task, and then after you finish it, try to do. I will make my own like expression for you. So so please do your like in class work. So please do the convert from infix to postfix for the expression here. Where is my content? Okay, here. Okay, do this, the green one there, and then do the one that I put it in the chat box. Okay, and like when you finish. Yeah, great. They're so fast now. You finish on the 3. The others, please like when you finish. Okay. Okay. So show me the result for the last expression. So what is the result for the last expression? Yeah, should A be division, okay, and then C D, E, and asterisk, minus, for the last one. Yeah. Okay, so that should be this one, like AB division. Okay, and then we are waiting for the result, so we say CD, E, asterisk, so minus and plus. Okay, like the one of the last one I see in the chat box. Okay. Okay, now after that, now I hope that you quite familiar with postfix and prefix. Okay, and now sorry, postfix and infix. Now what we try to see is that now when you have the expression like that, we will be able to evaluate the expression. Okay, what we call that will be the reverse Polish expression. Okay. Sorry, up. I can make it wrong. What I try to do is now see how can we compute the value. Okay. Now let's see. In order to compute the value, do you have any idea for that? To compute the value of the expression. If I have the expression like that, you see that somehow in the postfix expression, we already express the probabilities of the operation. Okay, so we have it. Okay, this one already tell us that here you see if we have priority on B and C, it's mean we do B, C first. Okay, here we have to do asterisk here, or this one, let's say we have priorities on the B and C, so you put this one. Okay, so you see that the postfix format have us to represent the expression and the priorities of the operation within that expression. Okay, in that way we can do what we say evaluate the expression. Now I will show you the algorithm to evaluate it. Okay, now what we can do is just play with this postfix. What we say, we will try to read it and using a stack. Okay, here you are, stack. Let's see what we can do. The algorithm is that we say A, we put A here. B, we put B here. And if we see the plus, it means any operation. What we try to do is, can you tell me, can you guess? When we see the operator, what we can do with that? What should we do in order to evaluate the expression? So we pop, yeah, of course we want to do A and B. Then what we say, we pop it out. Pop it out. So we get it out, A and B. And then we apply the operation for these two values. Okay. You get it? So we pop the value. Okay. So now after that step, after this moment, what we say, we pop it out and we get back the result. We push the result back to the stack. So we have A plus B here. The result of that operation. Of course, here I put the symbol, but in real life, if we have the number 10 plus 4 or something, we get the result here. Okay. And then we see number C. Yeah, see, we put it here. we say minus, we get out A plus B. Last time we have, okay, what we get here at the result, and we say minus C. Okay, so that is what we have here. Okay, so now let's try to play with this concrete example. You will see what does it mean by that. Right? Let's say we have this one. This is quite thing. So I have, let's say I will put number like 5, okay, and then we have like a 10, and then 1, okay, as ABC, okay, and then I have asterisk and plus. So what should we do? What can we do? We read it, we push 5 to the stack, okay, then we put 10, we have that, we have 1, okay, we have the asterisk, so we pop 10 and 1 out. We do application, multiplication at the result. What we have in here, 10 at the result of 1 multiplied by 10. Okay, if let's say, let's put it like this to make you continue with that. Okay, so let's say we have number 2 here, okay, and now if we reach this one, we get it out. What we have as the second at the result is that we have 20. We apply the operation and we push the result back to the stack, okay, and after this step, okay, and then this one we see plus, what we do, 20 plus 5, okay, 25. Everyone, is it clear for the reverse Poland expression? Okay, reverse Poland algorithms. Hello? Is it clear, everyone? Hmm? The others. Okay, so to make it a bit better for you, so I recommend you to like yeah, the operators will apply to the two previous operand. Okay, so let's say I would try to run it that way for you. Okay, so let's say what we can do. Yeah, so let's run it with this one. So let's say this one. Okay. So what we say, we have A, B, asterisk, C, C, D, asterisk, plus. Okay. So what we try to do, we try to apply the stack. So we say we see A. Okay, we say character A here. I will try to make it easier for you to look at. Okay. So we have A. So we have our stack. I will put my stack in the horizontal way, no? So let's say my stack is that way, in this direction. Okay. Okay. This is my stack. Sorry, the stack like that. Okay. So when we have A, we put A here. Okay. Then we after that we move to the second. So we move to the second characters here, and then what we got is we got B here. Okay. And then we got the asterisk operators. When we read it, okay, when we see get A, read A, and then we see B, we put it there, and then we see the character asterisk. Okay, what we do, say pop item, 2 items, the stack. Okay, so we pop it out, so we get what? B, and then A and B. Okay. And the second step we do is apply the operation. Yeah, on this item. Okay. So we have here A, the A, B. Okay. And next step will be push the result back to the stack. As the result, our stack will be okay, A plus B. A. Okay, everyone, is it clear? So our stack, we have it. And now what we try to do, we continue. We see A, B, we see there, we see the asterisk, we do many things. Okay, and then we continue with D, C. Okay. See the character C. So what we do, say, push to the stack. What we have a new stack with this one. And then we have one another thing is C. Okay. That is one character, no? One lot. Then what we continue with D. Okay. D, the D. I'm trying to do this better, but not really good. Okay. We see D. What we see, we push to the stack again. What we get the result, we have this with another character D. Okay. And then we continue with this. We have the asterisk. Okay, we apply the same kind of operation. It's exactly the same. Now we say we see the character star. What we do, we pop 2 items from the stack. Now 2 items will be C and D. Okay, apply. We have C and D. Okay, push it back. What we got is this one. The result of this. Okay. Then continue to read. We have plus, then we apply the same kind of thing. Pop 2 items from the stack. Now what we got from the stack is A, B. Okay, and then the second object will be C, D. Okay, and apply operation. So we have it. Apply operation. So we have plus. Okay, push the result back to the stack. This one to the stack and finish. Okay, everyone, is it better that way? And if we reach the end of the expression, we pop the result out the stack. That will be the final result of our expression. Okay. The others. Okay, it's good. Other student? Okay. Okay. Now it's better. Okay. Now we see that now our task is to you see that the magic thing actually is not from is not really like hard on the applying the operation on the postfix format. Okay, you see that with postfix, the rule that we can do or the operation we do in order to compute or evaluate the expression is quite straightforward. Get characters or its number, pop into a stack. If get operators, get out 2 items, apply and push back the result. That's it. We don't have the if, else. We don't need to say about priorities. They asterisk higher priority than addition and subtraction and so forth. We get priorities advantages over the others. So we don't need to say anything about that. The system just say C characters, C numbers, push C operator, pop and get it back. Okay, that is the thing. So what we try to do is we convert it to postfix. That is very important step to evaluate the expression. Okay, and now our next task is how to write a function that have us to convert from infix to postfix. Okay, you see that will be something that we should do in order to make the evaluation easier. Okay, so then now we move to the convert from infix to postfix. using a code. Okay, so imagine that we can do it, and of course we say we can do it like this one. The way we translate, we see it, we do it manually, step by step. A plus B minus, and we see the characters. Okay, I'll put it here. And of course, you see there is one thing that we have to check. Is this one. This one is this. Okay, and we will check on, we compare the probabilities between this one and the one that we get from the string. This means we say A plus B and minus. This moment is very important, because if this is an asterisk, so we will keep it somewhere and we continue to add C to the output. But if it is a minus, we can output the plus. Okay, so you see there's some if else statement there about the priorities of operators on the way that we do the infix from transfer from infix to postfix. Okay, and now you see that we do it. Now what people say that we can do it with a stack. So again, stack is, you see, used as a tool. Now to check. Okay, now have a look at how people use stack now. So you see that the way they do, again, stack is quite powerful tool. With this we read A, so with A here, so we A, so we have plus. What we do is we put the plus to the stack. Okay, then we have B, we write out to the output. Okay, we have this one. This one we push into the stack. Okay, this one we push to the stack. Okay, C, put output, minus, push to the stack. We have minus there. We have D, nothing to do with that. We are closing parenthesis. So what we have as a closing, then we get the minus out. Okay, and then we continuously pop the value out of the stack. So this one, nothing, we don't need to do anything. We put the asterisk here, and then we pop the plus here. Okay, so that is the case when we have a asterisk and then something. Now let's play a bit with the stack where we have the basic operation like A plus B minus C. Okay, to see what happened. Okay, now we have, if it is minus, okay, so we read it A, right to the expression. B, plus, put it to the stack. B, write out to the expression. Okay, minus, what we should do, if they have the same priorities, we pop the plus here. Okay, so the output will be A, B. Okay, and we have in the stack is the plus. Okay, and now we see the minus. We check the minus here. We say the minus had the same priorities with plus on the top of the stack. So we try to use a stack to compare between the priorities between the last operators and the current operators. So if they have the same priorities, we will put this one out. So I will out and remove it. Okay. I will push the minus here. Okay. So I continue. I have C. I put C to the output. Okay. And then we have this one. Okay. And finally, after we have nothing else, we put the minus out. Okay. That in that example, you see that if we have the same priorities, then we just, or the lower priorities, we just pop the operators out the stack. Here in the case that we have someone that have higher priorities than our operation, so we keep thing in the stack and continue to put it to the stack. That is the thing. Okay, so you see that people use stacks for that reason. Now everyone, I want you to play with this just to get familiar with the operation. Okay, so please play with this one. Okay, try to do this thing and maybe this thing with the stack. Okay, try to get it. So I will put it here back to A, and I will show you the slide back to so that you can read it. Okay, so we have two expression A, B, C minus D. Okay. Okay. Now everyone, your task to write this one like this table, step by step, what you read so far and the content of the stack. So everyone, please do it. Okay. Oh, sorry. So everyone, please do it. And like when you finish. And when you finish, like and share your and share your result. Okay. Thank you. Okay, so please share your result, please. Long, in your case, you're stuck in the inverse direction. On the left would be the top, you're stuck. Long, no? Yeah, because it's slightly different from here, no? From in the slide, yeah. Yeah. Okay, so the others, is it clear to you? And now, everyone else, can you finish it? So, okay, so let's say you finish it. You see that now we know how to do it manually. Okay, what I show you is that now we have the algorithms, how to do it manually, and how to convert it from infix to postfix, and then how to convert it from postfix, evaluate the expression. Okay, now when we sit back and think about the how to evaluate expression, you see that the value of the stack is quite like important here. That have us to compare with the last, compare the new and the last item that insert to the stack. In this case, you see that the stack have us to compare and have us to make decision on the priorities of the two operators here, the current, the latest operators, and the one that we just have before it. Okay, so here the stack has a great tool for us to compare the current value with the last inserted value. Okay, and again the stack have us to evaluate the postfix format. Just say every time we got it, we just get out the last two elements, and this is one of the source for the tool, for the name, like why people say stack can be used as a tool for primer. Okay, and now I think that would be the items. Your homework, I want you to do homework is to do this one. Okay, the homework is to read in the textbook. Okay, read the implementation of this way. Okay, so we will do the right if else statement for the convert from infix to postfix, and how to evaluate perfect and perfect expression. Okay, and in the last section we have one section that asks you to implement this reverse Poland algorithms. Okay, but at the homework, please read the textbook on the implementation, okay, of the converting from infix to postfix formats. Okay, and that's the end for the chapter stack and queue. Okay, we will see there's many other application of stack and queue. It's been because we want to access our data in first out order, or for first in last out order, or in the highest priority order. That is what we can say. And now everyone, if you have any other questions, so please ask me. Okay, thank you for your feedback and your result there. I love to see the result from you, so that I can comment and feedback on top of that. Okay. Okay, thank you everyone. So it's good Nhật and Kỳ and Luận to be active here, and the others, thank you for being active in class. Okay, and everyone else, do you have any other questions? Okay, otherwise that's it for today. Okay, thank you, and see you next week. Okay, it's good. Hope that now you get a bit, say a lot more thing. Okay. Okay, thank you. Bye bye.